In this lesson, we will be looking at finding the perimeter and area of different shapes. So first of all, if you're taking your notes, we're going to look at perimeter. The perimeter is the distance around an object. So if you had a yard and you were trying to put a fence around a yard, you'd be calculating how far that fence needs to be. It's the distance around. You find the perimeter by finding the sum of the lengths of the sides. And remember, the word sum means that you add the sides together. So all we have to do is figure out the length of each side and add them together. So if you look down here at figure A, which is right here, on the top part, if you were to count these units, you would see that it's 5 units across the top. It is 3 units on the right side, 5 units on the bottom, and 3 units on the left side. So to figure out the perimeter, we would simply add all of those numbers together. And 5 is 10, 3 and 3 is 6, and 5 plus 6 would be 16. For figure B here, you see that there's 2 units across the top. There are 1, 2, 3, 4, 5, 6 units on the side, 2 units on the bottom, and 6 units. So again, we would add up all of the sides. 6 and 6 is 12. 2 and 2 is 4. So the perimeter of that shape is also 16 units. Now we're using the word units because we are not told whether it's in centimeters or feet or what it is. So if you don't know what the unit is, we just use the word units. On the third shape, you'll see that there are 3 units across the top and 3 on all of the sides. So we could do this one. You could add 3 plus 3 plus 3 plus 3, but since it's the same number repeated, we could just go 3 times 4, and the perimeter of that shape would be 12 units. Down on the triangle at the bottom, I gave you that this diagonal right here is 5 units. Here you can count and see that there are 3, and on the bottom you can count and see that there are 4, and 3 plus 4 plus 5 would equal 12 units. So the perimeter is the distance around an object, and you can figure out that by just adding up all the sides. Now there are some equations that we use that can make it a little bit of a shortcut. So if we say write an equation for the perimeter of a rectangle, remember the perimeter is the distance around, so if the top is 12 centimeters, we know that the bottom is 12 centimeters. And if one side is 5 centimeters, we know that this one is 5 centimeters. So you could go 12 plus 5 plus 12 plus 5. Or since there are doubles, we have 12 twice and we have 5 twice, we write that as an equation that looks like this. P stands for perimeter. 2 times the base. Well, the base was 12, and we do 2 times that because the top and the bottom bases are the same. So we can say 2 times the base plus 2 times the height. That is because the height we had twice. So we use this equation right here. So if you're taking your notes, write this equation right here in your notes. To find the perimeter of a rectangle, we take 2 times the base and we add 2 times the height. So if we were to plug in the numbers from this particular rectangle, the base was 12, so in place of B, we put 12. The height was 5, so in place of H, we put 5. So perimeter equals 2 times 12 plus 2 times 5. Now, according to order of operations, we always do our multiplication first. So first we would do our multiplication of 2 times 12, which is 24, and 2 times 5, which is 10. And that gives us a total of 34 centimeters. And since in this shape they told us that the sides were centimeters, it's really important that we label it centimeters. Because 34, if you just say the perimeter is 34, there's a huge difference between 34 centimeters and 34 miles. So we need to use our units. There is an equation we use for the perimeter of a triangle. Remember, perimeter is the sum of all the sides. And on this triangle, all of the sides are different. So the basic equation that we would have is perimeter equals A plus B plus C. That means you're just going to take each of the three sides and add them together. So write this equation in your notes. Now, you might say, well, which is side A, which is side B, which is side C? Well, it really doesn't matter, because when you add all three numbers together, you're going to get the same answer. So you plug in 1 to each one. 10 plus 6 plus 8 would equal 24, and we label it centimeters because this also was in centimeters. Now, a square means that there are 4 equal sides. So what do we know about this? If one side is 10, we know that all sides are 10. So yes, you could go 10 plus 10 plus 10 plus 10, but because 10 is repeated 4 times, we can just say that the perimeter of a square is 4 times whatever the side is. And then if we plug in 10, which is the side, that's 10 times 4, and the perimeter would be 40 centimeters. Now we're going to move to area. Area is different. Perimeter was the outside. Area is the number of squares that covers the surface of an area. This is what you would use if you were putting tile down at your house or carpet and you need to know the square footage. So if you look at A right here, if you were to fill in these, whoops, I didn't do a very good job at that. Let's try that again. If you were to look at this, we have 1, 2, 3, 4, 5 along the bottom units, and we have 1, 2, 3 units along the side. So if we were just to show how many squares it took to cover that, it's 3 times 5, which is 15. Because we're making a grid, we just take our 3 times our 5. We're counting the number of squares it takes to cover the entire unit. It's different from perimeter. Now, since we're counting squares, when we label it units squared with the exponent of 2 to show that we're counting squares. In figure B, across the top we have 4 units. Across the side we have 4 units, although that doesn't really look like a square, does it? I don't think if we were to break it up into a grid, you would see that we have 16 squares that cover it. All we had to do was do our 4 times our 4. Again, we multiply the base times the height and get 16 units squared, or square units. Now, for a rhombus or a parallelogram, if you look right here, the cool thing about this is if I were to cut off this part of the triangle, you could paste it right here. And if you were to paste it right there, and this were to go away, you can see that you have a rectangle or a square. So we actually use the same equation because it's covering the same amount of space. So if you can figure out the base, which here is 3, and we have to have what we call the perpendicular height. You don't want to do the slant height because that's not going to be the correct number. But you want to know how many it is up and down, and that is 2 up and down, 3 across the top. So 2 times 3 is 6 square units. Now, if you were to look at a triangle, we have an equation that we use for a triangle to figure out a triangle. A triangle, if you have a rectangle or a square and you were to cut it into 2 parts, you would form 2 triangles. Same thing with a square. So if we know that the area for a rectangle or a square is base times height, we can take that same equation and divide it by 2 because a triangle is half of a rectangle. Now, you can decide what you prefer to do with your calculator. You can either type in the base times the height, push equals, and then divide by 2. When you're dividing by 2, it is the same thing as multiplying times 5/10 because the decimal 5/10, when simplified, is 1/2, where you're dividing by 2. So if you don't like dividing by 2 with your calculator, you can do the same thing by doing base times height and multiplying times 5/10. Same thing as dividing by 2. You can do either one with your calculator. So this is the equation you need to write down that we use. Now if we plug in the numbers, we have the base times the height divided by 2. Or if you want to do the other method, it's base times height times 5/10. So you type it, you can use your calculator for this. 18 times 3 equals divided by 2, or 18 times 3 times 5/10. And you're going to get 117 square centimeters. Area is counting squares, so when we label it, we put squared. For a rectangle, the equation is base times height, because we're making a grid. So we simply plug in the numbers 18 times 7, and 18 times 7 is 126 square centimeters. So you can write this equation right here. It's the equation we're going to be using for rectangles. Remember that with parallelograms or rhombuses, they're just like rectangles, because if I were to cut off this triangle and glue it right here, and this went away, you would have a rectangle. So the equation is the same because you're covering the same amount of space. But you have to have what we call the perpendicular height, which is the base and the line that goes straight up that forms a 90-degree angle. You cannot use the slant height. You have to use the height that comes straight up from the base. So for a parallelogram, we have the same equation as a rectangle, except make sure that the height is the perpendicular height. That means that line that comes up from the base at a 90-degree angle. So this would be 20 times 8, which is 160 inches squared. This is probably the hardest one. It's a trapezoid. So let me show you the equation that we use. Area equals, and in parentheses you're going to add together the two bases. The bases are the two lines that are parallel to each other. Those are the bases. So first you're going to add the bases together and multiply it times the height. Now remember, with a rectangle, is base times height. We're basically doing the same thing right here, but we have to add the bases together first. And then, because we have these triangles over here to the side, we have to divide by 2 like we did with the triangle. So it's kind of a combination of the two equations. So if we look up here at this one, first we're going to plug in all the numbers. So the top base was 6. The bottom base was 10. We're going to add those two together first, which would be 16. We're going to multiply it times the perpendicular height, which is 5. So that would be 60 times, sorry, I multiplied instead of adding. Silly me. 16 times 5 on top. And then when you figure that out, you're going to divide by 2. Or if you prefer, you can multiply times 5/10 again. And 16 times 5 is 80. And 80 divided by 2 is 40, so it's 40 square centimeters. So you need to write this equation down so that you can remember it and know how to plug in the numbers for it. Now on this particular rectangle, notice that they give you the area. But we know that the equation was area equals base times height. They give you the area, so this is the number that you plug in to A for area. They do not give you the base, that's unknown, but they give you the height. So we're going to plug this in for H. So what you're actually going to be solving for is the base right here. So if we plug in 242 to the area and 11 to the height, it's 242 equals 11 times the base that we don't know. This creates a one-step equation that we've been working on. And to solve for the variable, since the variable is being multiplied times 11, we have to divide both sides by 11 to solve for the base. 242 divided by 11 is 22 centimeters. So once you know these equations, you look at what information they give you and you just plug it into the right place in the equations, and then you can use your knowledge about solving one- and two-step equations to figure out the answer. Here's a triangle. Remember, our equation for the area of a triangle was area equals base times height divided by 2. In this one, we know the area and we know the height, but we do not know the base. So when we plug in these numbers, we plugged in 50 for the area, right here. We plugged in 18 for the height, but we don't know the base. So we would use our two-step equation or a one-step equation to solve this. You could set it up this way, or you could do the 0.5, and then you only have, well, it makes it probably a little bit easier. But when solving this, you can just think of it this way. What is half of 18? Well, half of 18 is 9, so that would give us 50 equals 9 times b. Now you divide both sides by 9, and you're not going to get a decimal, 5 and 55 hundredths. So you plug in those numbers, and then you solve it using what you know about solving two-step equations. And that is perimeter and area of different shapes.